This section is covering rationalizing the denominator. So let's say, for example, you have a problem that starts with the square root of 8 minus the square root of 2, and you want to multiply that by the square root of 8 plus the square root of 2. Well, what you would do is a bunny hop. So you start the square root of 8 and you multiply it times square root of 8. So that will give you the square root of 8 squared. Or you can call it the square root of 64. Because when you multiply roots, if you have square root of a times square root of b, that will give you the square root of a times b, all under one square root. So instead of saying the square root of 8 squared, we can say that's the square root of 64. And then we take the square root of 8 times square root of 2, that'll give us positive square root of 16. Then we start with the bottom. Negative square root of 2 times square root of 8 will give us a negative square root of 16. And negative square root of 2 times square root of 2 will give us negative square root of 4. So what happens is the middles cross out, and you have square root of 64, which is 8, minus the square root of 4, which is 2, which gives you a 6. So if you look at this, this looks a lot like the formula a plus b times a minus b. And that formula is called the difference of squares. So you have a squared minus b squared. So when you look at the problem again, square root of 8 minus square root of 2 times square root of 8 plus square root of 2, that's almost like this formula right here. So when you look what the formula does, it squares the a and it squares the b and the subtraction. So we'll square the 8, which is the a, and we'll square the b, which is square root of 2, and we'll subtract it. So you'll have 8, because the square root of 8 squared is 8, minus square root of 2 squared, which is 2, which gives you 6. So instead of going through the whole bunny hop process, you can apply it to the formula. If all the letters are the same, the a's are the same, the b's are the same, only thing that's different is a plus and minus sign. So this is how you would rationalize in a denominator that looks like that. Let's say you were given the square root of 2 plus 1, and you wanted to multiply that by the square root of 3 minus 1. Well, this doesn't follow the formula, so therefore you have to multiply it out. So you have square root of 2 times square root of 3, which gives you square root of 6. Square root of 2 times the negative 1, which gives you negative square root of 2. And 1 times square root of 3, which gives you a square root of 3. And 1 times negative 1, which gives you negative 1. Well, that's as far as we can go with this problem. So therefore, the square root of 6 minus the square root of 2 plus the square root of 3 minus 1 will be the actual answer for this problem. Now let's rationalize the denominator. What that means is you're not supposed to have a root of any kind on the denominator. So for example, if you have a problem that says the square root of 7 divided by 2, that can individually be broken up as the square root of 7 divided by the square root of 2. Well, you're not supposed to have the square root of 2 on the bottom of a fraction or any kind of root. So what you do is you multiply it by itself, because when you square a square root, you get what's under it. So square root of 2 times the square root of 2 is going to give us 2. And then when we multiply the top, we have the square root of 14. So the answer is square root of 14 divided by 2. Let's say you have negative 8 square root of 3 divided by k. Same situation, divided by the square root of k. This is the same situation. You're not supposed to have a square root on the bottom. So what you do is you multiply it by itself. This is only true for square roots. When you go to cube roots and fourth roots, you have to do something different. And whatever you do to the bottom of a fraction, you have to do to the top. So what you end up with is a negative 8 square root of 3k all divided by k. And this is as far as you can go with this problem. It's simplified already. So let's do one last square root, and then we'll go to a different type of root. Let's say we have negative square root of 48 k squared divided by 2. So when you individually write this out, it'll be a negative square root of 48 k squared divided by the square root of 2. Well, you can't have the square root on the bottom, so what you do is you multiply by the square root of 2 times the top and the bottom of the fraction. So what you'll have is you'll have a negative. If you break 48 up, 48 is 8 times 6, which is 2 times 2 times 2 times 2 times 3 times 2 k's, and then a 2, the last 2 that we multiplied by it. And then that's all divided by 2, because when you multiply the square root of 2 times the square root of 2, you just get 2 out. Now, the number of things you can pull out of a square root are squares. So these two 2's will come out as 1, 2. These two 2's will come out as 1, 2. And then these 2 k's will come out as 1k. So you multiply all that together, and in the front you have a negative 4k square root of what's left under there, which is the 3 and the 2. So 4k square root is 6. And all of that is divided by 2. Now you can simplify, since you pull something out, you can simplify the 4 and the 2, and that'll give you a negative 2k square root of 6. So this is your final answer. Okay, let's move on to cube roots. So let's say you have the cube root of 2 divided by 3. Well, that can individually be written as the cube root of 2 divided by the cube root of 3. Now, one thing you must know about cube roots, to simplify a cube root, let's say the cube root, you would have to have 3 identical things under there. Because you can only pull 3 things out of a cube root. So if you have the cube root of k to the third, then those 3 k's will come out as 1k, and your answer will just be k. Since you have nothing else under the cube root, the whole cube root goes away. You have to think about that when simplifying something that had a cube root on the denominator. You have the cube root of 3 on the bottom. So what you need is the cube root of 3 3's, so that those 3 3's can come out to be equal to 3. So you're missing 2 more 3's. So the only thing you can multiply times the cube root, say the cube root of 4, is another cube root. So you can only multiply cube root times the cube root in order for them to make sense. So if we're missing 2 more 3's, we have 1, then we multiply by the cube root of 9. Because that's our 2 3's that we're missing. And so whatever you do times the bottom, you have to do times the top. So what you'll end up having is you'll end up having at the top a cube root of 18. And at the bottom, you'll end up having a cube root of 27. And then when you simplify it, you'll have the cube root of 18 at the top, and you'll have the cube root of 3 times 3 times 3 at the bottom, which the 3's cross out and just give you 1 3. So your final answer will be the cube root of 18 divided by 3. So let's say you had the cube root of 4 divided by 9. Well, that's the cube root of 4 divided by the cube root of 9. So, since it's a cube root and you only have 1 9, you need 2 more 9's down there. So what you multiply is by the cube root of 81, because that's your 2 9's. So whatever you do times the bottom, you have to do times the top. And so you have to multiply both the top and bottom by 81. The bottom is going to be, you take 81 times 9, that's going to give you the cube root of 729. A shortcut, it'll be cube root of 9 times 9 times 9, instead of multiplying everything out, because you know you're going to need to simplify that cube root. In the top, you take 81 and you multiply it times 4, and that'll give you the cube root of 324, or 2 times 2 times 9 times 9. So we're simplifying this. When you look at the bottom, the 3 9's cross out, and so you'll end up with just a 9 on the bottom. When you look at the top, you have the cube root of 2 times 2. Those 9's can individually have their own 3's, because 9 is 3 times 3. So you actually have 4 3's under there. And so cube root says 3 things come out that look alike. So what the answer will be is a 3 cube root of 12, because you take the 2 times 2, which is 4, multiply it times the 3, which is 12, divided by 9. And that can be simplified because 3 can go into 9 3 times. So your final answer would be the cube root of 12 divided by 3. So let's try a fourth root. Let's say we have the fourth